something called mutually exclusive. Okay? Mutually exclusive means that two events can't happen at the same time. Think about it like if you're dating somebody and you're exclusive. You can't date somebody else, right? So if you're mutually exclusive, can't goes with it, all right? If it's not mutually exclusive, the two things can happen at the same time, and that's sort of opposite of like the words, but that's how it goes. So two events that occur at the same time are, or that cannot occur at the same time, are mutually exclusive. And out to the side, I'm just going to write can happen at the same time. Is not mutually exclusive. A junior winning the election or a senior winning the president of student body election. Let's just say the two elections it's talking about is the student body election. Can the junior win and the senior win at the same time?
No.
No. Can't happen. So mutually exclusive or not?
Yeah. Mutually.
It is mutually exclusive. I'm going to abbreviate with that with a ME.
Oh, wait, Addie. I just answered it for you. Okay.
Number 2, drawing an ace or a club from a standard deck of cards.
Yeah.
Okay, so let me talk a little bit about cards. You may or may not know things about cards, but with cards, there's a 52 standard deck. Okay, there's 52 total cards. When you look at cards, there's black cards and there's red cards. Half and half. So there's 26 of each. Okay, when you look at the black cards have the little symbols on them. They're either clubs or spades. The red cards have symbols. They're either diamonds or hearts. That means there's 13 of each of those. Okay? And the 13 cards that they have for each of them, it's 2, 3, 4, 5, 6, 7, 8, 9, 10. And then Jack, Queen, King, Ace. That's what I mean by when I say the 13 cards is 2 through 10, Jack, Queen, King, Ace. Okay, that's the 13 that's in each one of these. So there's 4 2s, and there's 4 3s, and there's 4 4s, all the way up to 4 aces. Okay? Face cards are cards that have a face on them. So the ones that have faces are Jack, Queens, and Kings. So those 3 cards have faces, and each suit has one. So there's 12 of those. So you're going to need those cards at some point. If you don't know anything about cards, you might want to write it down. Okay. The question, though, that it asked on number 2 was, could you draw an ace and a club at the same time?
Yeah.
Yes.
Yes, you can. Because there is an ace of clubs. So because you can do it, does that mean it's mutually exclusive or not mutually exclusive?
No.
Okay.
Okay, that makes sense now.
Not the next one was getting a sum of 6 or a 7. Okay? So we're rolling dice. And we look at the 2 of them. Let's say it's a 3 and 4. If I add it together, that's 7. I can get a 7. Okay? Roll them again. Look at them. Maybe it's a 4 and a 2. That adds 6, so I can get a 6. Okay, when I roll it and I look at the 2 numbers, can they be a 6 and a 7 at the same time when you add the numbers?
No.
Yes.
The sum can be a 6 and a 7?
At the same
No,
time?
not the
No.
sum.
Well, it says a sum.
One can be 6.
So we're talking about a sum of a 6 or a sum of 7.
No.
No.
That can't happen at the same time, so
Mutual exclusive?
it is mutually exclusive. Okay, so let's talk about the probability of finding a 6 or a 7. Okay? Sometimes you can't just look at the spinner and add up how many things add up to whatever it is and divide by the total. Sometimes you have to write out the sample space. And the sample space is a list of possibilities. Okay? So, first thing I want to do is list all the ways that you can get a sum of 6 when you're rolling dice.
That's a lot.
So, what could it be that would give me a 6?
1 and 5.
A 1 and a 5. Notice you could also have a 5 and a 1 with the different dice. Okay?
Also, we're getting
What was another one?
those.
3 and 3.
3 and 3. Okay.
4 and a 2.
4 and a 2.
2
And a 2 and a 4. Any others? No. That's the only possibility is to get a 6 when you add the two numbers.
So do you have to do like a 1 and a 5 and a 5 and a 1?
Mm-hmm.
So that's not
That's
15,
stupid.
51.
No, it's a 1 and a 5. It's a 5 and a
I
1.
put a plus between them so I wouldn't get confused.
Okay, sum of 6. I mean, sum of 7.
6 and 1.
So 6 and 1,
1 and 6.
and a 1 and a 6.
3
5
and
and
4.
2.
3 and 4. 4 and 3. I heard 5 and 2.
2 and 5.
Yeah, I just didn't put commas in them because that would have been a lot of commas and I was afraid you'd get confused. But anyway.
I put a semicolons.
So how many is that?
1, 2, 3, 4, 5, 6.
6.
For number 6?
I'm wanting a sum of 6 or a sum of 7. So all of that's got to go together. So there's 11 of them. Then I have to figure out, okay, how many total possibilities do we have? Now, I'll show you later, but there's a chart that you can make with dice that you list like 1, 2, 3, 4, 5, 6 on the top, and you list it on the side.
36 or something like that.
And then so like 1, 1's a possibility, 2, 1, 3, 1, and then so on. And if you multiply 6 by 6, you'll get 36. So 36 is the total number of possibilities. So the probability that you would get a sum of a 6 or a 7 is 11 out of 36. And if it's not mutually exclusive, or if it is mutually exclusive like on this problem, you just add up the possibilities and divide by the total. You just have to think about those possibilities sometimes. Okay? Question so far?
No.
So it says that the events are not mutually exclusive. Let's talk about it. It says rolling a number greater than 2 or an even number. Can you roll a number greater than 2 and an even number at the same time?
Yeah.
Yeah, you can. So that's why it's not mutually exclusive. Okay? So what we're trying to do is we're trying to figure out that probability of getting a number greater than 2 or getting an even number. Now, there's a couple ways to do it. I'm going to show you the longer way first. I think the longer way is using the formula. But then I'm going to show you the way that I would probably do it if I could. So,
Consider changing your password.
Come on, Miss
okay,
Jones.
so probability of A or B, one way to do it whenever it's not mutually exclusive is to figure out the probability of A and then add probability of B. But you have to subtract off the probability of not A and B. Okay? And I'm going to show you a Venn diagram, although you don't have to do it this way. Okay? So, if this is a Venn diagram, we're going to let A be numbers greater than 2. Okay? Well, what numbers are greater than 2?
3, 4, 5, 6.
I'm just going to put a 3 and 4 in there. I mean 3 and 5, sorry. Because my other one is even numbers, and I know 4 and 6 are even, so I'm going to go ahead and put that in there. Okay? And what are some other even numbers that aren't included? That are even?
2.
8.
2.
Wait. Like below?
We're doing a die, so it can't be above 6. So 2 is the only one. So greater than 2 would be 2, 3, 4, 5, or greater than 2 would be 3, 4, 5, and 6. And so I listed 3 and 5 separately from the 4 and 6 because 4 and 6 is included. Okay? So if I want to figure out the probability of or, well, there's 1, 2, 3, 4, 5 ways to get it. Okay? Now, to use the formula, the probability of a number greater than 2 is 4 out of 6 because 3, 4, 5, and 6 are greater than 2. The probability of getting an even number is 2, 4, and 6. So that's 3 out of 6. But then you subtract off the number in common, which in this case is 4 and 6. So there's 2 that you would subtract off. So it's 7, 6 minus 2, 6, which is 5, 6. This is the final answer. But see, I don't think that you have to do it that way, although I think that formula is important. What you could do is just add it up. I know that numbers greater than 2 are 3, 4, 5, and 6. And even numbers that I've not already listed is a 2. So there's 5 of them and out of a total of 6. So if it were me, I would probably do it the second way where I just list the possibilities.
The first way was way confusing.
Yeah, the first way is really freaking.
So since we decided that the second way is easier, we're going to do this next one a different way. We're not going to do it the way that they have it listed. Okay, we're just going to sort of talk about it. It says that we want to find the probability of drawing an ace or a club. Okay, how many aces are in a deck?
13.
4.
Oh,
4. There's 4 aces.
Spades.
Okay.
Club.
How many clubs are there?
13.
13. How many aces and clubs do we have that are the same?
2.
Like-
You just subtract 13.
4.
Okay, the aces that are listed here,
Yeah.
1.
clubs, spades, diamonds, and hearts. That's my 4 aces.
Yeah.
Okay. Clubs are all the numbers including an ace. Okay. How many cards are an ace and a club where I've listed them twice?
1.
1.
Only 1. So I'm going to figure out how many cards I have that are either aces or clubs, you're going to add that, but you're going to subtract off one of them. Because that 1 I included in the 4 and I also included in the 13. Does that make sense? So you get 16, okay? But because it's asking for a probability, you have to divide it by the total, and the total is 52. And so this is our answer. The complement of an event is the opposite of the thing happening. It's all the outcomes not in the event A. So, like, if I was talking about the aces up there, but the complement would be not an ace. Or if I was talking about my dice, and I wanted the even numbers, my complement would be not an even number. Okay? And if you want to find the complement of an event or not the event, you just do 1 minus the probability of the thing. Or you just subtract from the total to figure out. So, example, the first one says probability of not drawing a club. Okay? How many clubs do we have?
13.
13. So if I don't want to have a club, how am I going to figure it out?
You should
Track 1.
I want to subtract 52 minus 13 to figure out how many are not clubs. Okay? I think you get, it's 39 and then out of 52. See, the probability of drawing a club is 13 out of 52, and if you do 1 minus it, you would get this. I tend to just try to think about it, how many are not clubs, and then divide by the total. But you could do 1 minus the probability of it. Okay, probability of not rolling a 6.
5 out of 6.
How many are not 6s?
5.
5. And there's a total of 6, so 5 out of 6 would be your probability.